Once again, welcome to my channel Physics Ke Pathshala. Today I am presented before you to discuss some basic mathematical tools in brief, to which frequently we will use in the class 11th physics. So before really discussing the concept of the physics of the class 11th, let us understand some basic mathematical tools to which frequently we will use. It is essential that we must be very well aware of these mathematical tools and their application in the physics. Today I am going to discuss a very important mathematical tools called binomial theorems. Binomial theorems, as the name suggests, this is the combination of these two terms. First one is the bi and another one is the nomials. Binomials, this is the combination of these two words. Bi means the two and nomial means the terms. That is the terms which is formed because of the combination of the two terms, that is known as the binomial. And the theorems which is dealing with such kind of the terms, such kind of the expressions which have the two terms, then it is known as the binomial theorems. In general, in very short or in very brief, if we want to discuss the binomial theorem, then it goes like that. As per the binomial theorems, if n is any integer, positive or negative or a fraction, and x is any real number, then 1 plus x to power n can be written as 1 plus nx plus n into n minus 1 by factorial 2 x square plus n into n minus 1 n minus 2 by factorial 3 x cube, and so on. It will continue and so on. Here the factorial means, suppose factorial, here we are writing factorial 2, factorial 3, factorial 4, so on, factorial n up to we will write. So what is the meaning of the factorial? What we have to do, we have to multiply the terms from the given terms to the one. That is, factorial n can be written as n into n minus 1 into n minus 2 into n minus 3 and so on up to the 3, 2, 1. At the last, 1 should be there. So we can say that if you want to calculate the factorial 5, then it will be 5 into 4 into 3 into 2 into 1. Factorial 7 can be written as 7, 6, 5, 4, 3, 2, 1, like this. In this way, we can calculate the value of the factorial for any given terms. Here, this is one of the statement of the binomial theorems to which frequently we will use. Actually, the binomial theorems for any index or binomial theorem for any other numbers, it is a matter of the physics. But in the it is a matter of the mathematics. But in the physics, frequently we will use this one, and with this one we can understand the concept of the physics. Here, if mod of x is less than or very smaller than 1, then we can neglect the higher power, higher order terms. So on that case, we can write 1 plus x to power n is equal to 1 plus nx, and the remaining terms we can neglect, because if the x is smaller than 1, then we can understand the x square will be much more smaller, x cube will be further smaller, and x to power 4, as the power will increase, the value will decrease. So we can neglect those terms. If in the case of mod of x is smaller than, much more smaller than 1, then we will use 1 plus x to power n is equal to 1 plus nx. Similarly, we can write 1 minus x to power n. 1 minus x to power n means, here what we have done, instead of the plus x, we have write here the minus. So wherever here the x is coming, instead of the x we have to put minus x, then the result can be generated for the 1 minus x to power n. So here if we write the 1 minus n x for the x, we will write minus x, then it will be converted to 1 minus nx. Here 1 n into n minus 1 by factorial 2, and here minus x to power 2 means the x square. It will be converted to the positive, so directly we can write x square. But here again the minus x to power 3 will be here, so a minus sign will be generated, so we can write n into n minus 1 n minus 2 by factorial 3 into x cube, and so on. Here very easily we can observe that first term is the positive, second term is the negative, third term is the positive, fourth term is the negative, that is alternatively positive and negative terms are appearing. In this way we can write for any other, suppose similarly we can write for the 1 plus x to power minus n for the negative integers, or for any other fractional numbers also if we are considering, then we can use these theorems. But this is the point of a concept of the mathematics, or the this is question is to be discussed in the mathematics part, but here in the physics parts only this much is the sufficient for us. Maximum times we will use only this concept. So in this way I think binomial theorem is clear. Here one more important thing we have to understand: if the power of the n is equal, power of the 1 plus x to power n is there, if the power is n, then the number of the terms will be equal to n plus 1. Let us apply and understand the binomial theorems very easily. And earlier we have studied that 1 plus x to power n, or 1 plus x to power 4, or 1 plus x to power 6, like that we have expanded several times. Now let us use a very common terms to which we are using from the class 6th, 7th, 8th, a plus b to power 2. This was the expression to which we are using since our childhood. Let us apply the same binomial theorems here. Then we can write a square comma, common we are taking, b plus a ka whole square, or to this we can write a square. Let us apply the binomial theorems. So we can write 1 plus nx 2 into b by a plus n into n minus 1, n is equal to 2 into n minus 1 by factorial 2 into x square. So that is a b by a ka whole square. And further if we will write, then it will be converted n into n minus 1 into n minus 2 by factorial 3 and b by a whole cube. Very easily we can see that here it is a 2 minus 2, so it is a converted to the 0. So further terms will be also converted to the 0, because in each and every terms the 2 minus 2 will be generated. So all the other terms will be get cancelled out. So here what we can write, a square 1 plus 2b by a plus 2 into 1 by 2. Factorial 2 means 2 into 1, again we can write factorial 2. So b square by a square. If we multiply them, then we can write a square 1 plus 2b by a plus b square by a square, or let us multiply the a square here inside, then we will get 2ab plus b square. This was the formula to which frequently we were using from this our childhood. Here one thing we can see that if the power is the 2, the power of the binomial term is 2, then the number of the terms are 3. One number of terms is increases, that is the number of terms will be equal to n plus 1 in general. If the power, here we are writing a plus b to power 50, then the number of the terms will be equal to 51. I think now it's okay. So similarly we can use this concept for any other integer or the powers. Suppose we want to find out a plus b to power 60, or let us consider a small one, a plus b to power 6. In the same way you can do yourself. Try to repeat these questions, try to solve by yourself, so that you can get the better understanding. Earlier in our classes 6th, 7th, 8th or up to class 10th, if such kind of the expressions is there, then it takes a very hard work for us to solve them. But here, because of the using this one, now we can easily solve them. Okay, whatever we have discussed up to here, that is the pure application of the binomial theorem in the mathematical field. Now if we want to discuss the same binomial theorems in the physics field, then we have to discuss its application in the physics. For that, let us consider an example, a question I have taken here. The acceleration due to gravity at a height h above the surface of the earth whose the radius is the r, radius of the earth, is given by g dash is equal to g r square by r plus h whole square. If the h is much more smaller than r, then show that g dash is equal to g 1 minus 2h by r. This question says that, as we have studied in the class 10, that whenever we are moving upward to the surface of the earth, if the radius of the earth is r, if we are moving upward to the surface of the earth, then the value of the gravity is decreasing. For that, the relation is given g dash is equal to g r square by r plus h square. I think up to class 10th we have not studied this relation, but here in the class 11th we have to discuss, or we have to read out. In the subsequent chapter we will prove this one also, but here as per the application part, we are assuming this is the correct. Then we have to show that if the height raised from the earth of the surface, that is a very much smaller than the radius of the earth, then in that case the g dash, that the acceleration due to gravity at the height h, can be represented in the terms of the g 1 minus 2h by r. So let us try to apply the binomial theorem to solve this one. Here we have get g dash is equal to g r square by r plus h whole square. Let us write this one as a g r square by, from this terms, lower terms, let us take r square common, then it can be written as a 1 by 1 plus h by r whole square. This will be cancelled out. So to this we can write g 1 plus h by r to power minus 2. If you are making this one term to the numerator, then it will be converted to the minus 2. Now let us apply the binomial theorem, 1 plus x to power n. So what we can write, g 1 plus nx, instead of the n, x means h by r. Now n into n minus 1 by factorial 2 into h by r square, and so on. It will be goes like this. It will be continue like this. But as given, r is much more greater than h, so h by r is very much smaller than 1. Here in the question they have given the r is very much greater than the h, so this h by r will be very much smaller than the 1. जैसा कि r हमारा बहुत बड़ा है, h छोटा है, तो h by r करने पर वो 1 से कम हो जाएगा. अगर इसकी वैल्यू 1 से कम हो जाएगी तो h by r का स्क्वायर करेंगे हम तो और छोटा हो जाएगा, क्यूब करने पर और छोटा हो जाएगा, इसलिए बाकी के टर्म्स निगलेक्ट किए जा सकते हैं. सो हायर टर्म्स कैन बी निगलेक्टेड. In that case, it will be converted to g dash will be equal to g 1 minus 2h by r. From here we have neglected all other terms, then it can be written as g dash is equal to g 1 minus 2h by r. This was the required result, hence proved. Similarly, we can use the binomial theorems for other expressions, to prove the other expression like this one. This is the pure application of the binomial theorems for the physics. Here, in this way, we have briefly discussed the concept of the binomial theorems and its application in the physics. Try to solve some more problems for the better and concrete understanding for the physics and binomial theorems. In this video, we stop our discussion here. To remain updated, kindly don't forget to like, subscribe and share my channel Physics Ki Pathshala. Thanks a lot and bye bye till next video. Thanks.